All right, multiplying and dividing fractions. Actually, a little easier than adding. You do not need a common denominator. Maybe we could write that here. No common denominator required. Okay, so you don't have to find a common denominator. The rule for multiplying is you really can just multiply the numerators together then multiply the denominators together and then reduce. Multiply the numerators together, the denominators together, and then reduce. So let's do an example. 1/3 times 2/5. You're just going to take it from here, multiply straight across. 1 times 2 is 2. 3 times 5 is 15. Can we reduce this? No, we cannot. We're done. All right, let's try another one. Let's say 3/7 times 14/15. All right, this one's a little harder here. 3 times 14, 42. 7 times 30, or 15. I'm doing the next part in my head. You can reduce this, looks like by 7 at least, so that's 6, 15. Oh, now you can reduce by 3. That was a pain, right? Let me show you an easier way to do that one. We can use something called cross-reducing. Let's do the same problem. 3/7 times 14/15. So, just how you reduce here, you divide both the numbers by the same number. So we divided these both by 7, we got here. We divided these both by 3, we got here. You can do that with any numerator and any denominator. So they don't have to be right on top of each other, they can be diagonal. So check this out, the 3 and the 15, can you take something, the same number out of both of those? Yeah, you can. You can divide them both by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. Here, you can divide these both by 7, right? 7 divided by 7, 1. 14 divided by 7, 2. Check this out. 1 times 2 is 2. 1 times 5 is 5. We got the same answer that we got before. In my opinion, that's much easier. So I always look to cross-reduce first. Let's try one. So I'll actually give you 3. 2/3 times 6/10 times 7/14. You can reduce any numerator with any denominator. So, I mean, you might have different options. I'm looking at the 3 and the 6. Divide those both by 3. You're left with a 1 and a 2. We could do the 2 and the 14. Actually, we could do this 2 and the 14 or this 2 and the 14. Pick one, doesn't matter. Divide them both by 2. That's a 7. Oh, the 7 and the 7 we could do. 1 and 1. This 2 and the 10, we could divide those both by 2. 1, 5. Oh my goodness, we got them all. So 1 times 1 times 1 is 1. 1 times 5 times 1, 5. All right, so if you can find those cross-reducings, it makes the math much easier. And let me just throw one in here with a negative. Negative 2/5 times, I don't know, 3/10. Now, when they write a negative in front of the fraction like that, that is the same. This is the same as writing negative 2/5 like that, or putting the negative down here. So there's just one negative, basically. They don't care where it goes, but it just goes in one spot. what does it mean for us? It means we have a negative times a positive. It means our answer is going to be negative. You might want to just throw it down there ahead of time, just so you don't forget what your answer is going to be. Look for any reducing. Oh, the 2 and the 10, we could divide those both by 2. And that's all we can do. We can't go a denominator with a denominator. So 1 times 3 is 3. 5 times 5, 25. So we have a negative 3/25. Okay? If they give you a mixed number, so that'll be our next note here. If you start with mixed numbers, you must make improper first. All right, this is something you have to remember. You have to do this. You can't, like how we were keeping the numbers, mixed numbers for adding and subtracting, you can't do that for multiplying. So what do I mean? I'm up to number 5 here. So let me give you a problem. Like 3 3/5 times 1 1/2. Okay, before you start doing anything, you have to make those improper. So you take the whole number times the denominator, add the numerator. So 3 times 5 is 15, 16, 17, 18, and you keep that denominator. This will be 1 times 2 is 2 plus 1 is 3 over 2. Now you can look to see if you can reduce anything. I'm looking at the 2 and the 18. I can divide those both by 2. That's all I can do. 9 times 3 is 27. 5 times 1 is 5. And yes, this could happen. If you get an improper fraction as your answer, you do have to turn it back into a mixed number. So how many times does 5 fit into 27? 5 full times, right? That gets you up to 25, because 5 times 5 is 25. 2 more to go. So that is going to be 5 2/5. All right, and again, if this was, let's say, a negative 3 3/5, I would make this a negative, and then your answer would be negative. Okay, so same rules apply with the negatives. Watch out. If both these numbers are negative, we would have got a positive. All right? Okay, so I think that's good for multiplying. Now let's talk about dividing. Now, dividing fractions is the same as multiplying by the reciprocal. Oh boy, what is a reciprocal? A reciprocal is, well, let me write it like this. Two numbers are reciprocals if their product is 1. What does that mean? So let's say we have 2/3 is a number. 2/3 times what is going to give you 1? Well, it turns out if you flip it, this is the reciprocal of 2/3 because they flipped spots. Watch what happens. We can reduce, divide these both by 2, divide these both by 3, and there's your 1. So the reciprocal is always flipping it. So this is where I think you guys were saying earlier, this is your keep, change, flip kind of stuff. So let's do an example here. 2/3 divided by 5/6. Okay, so we're going to keep the first number the same. We're going to change the division to multiplying, and we're going to flip the second number to the reciprocal. Now it's just a normal multiplying problem. So you're going to look, can you reduce anything? 2 and 5, no. Ooh, 3 and 6, yes. Divide these both by 3. And then multiply across. 2 times 2 is 4. 1 times 5 is 5. And you're done. All right, so anytime you see division, we're going to change and change. Keep, change, flip it to the reciprocal. Okay, you try one. Let's see. Got more here. Try 7/8 divided by 1/16. Okay, rewrite it first and then figure out the answer. All right, so 7/8 times, I'm going to flip this to the reciprocal, 16 over 1, and then I'm going to look to reduce. This can be divided by 8, divided by 8. 7 times 2 is 14. 1 times 1 is 1. That's just 14. Does that make sense? 7/8 divided by 1/16 is 14. It does make sense. I'll try to just draw a picture. If you had a pizza pie and you cut it into eighths, okay, so you have 7/8. So picture you have 7 of these pieces. Okay, and you want to know how many 16ths fit in the 7/8. Well, a 16th is half as big, so if I cut these in half, so how many 1/16ths fit in 7/8? How many do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's why your answer is 14. All right, look at another example. 6 divided by 2 is 3. That's saying how many 2's fit into 6? 3 of them. This is the same thing. How many 1/16ths, so how many of these little pieces fit in the 7/8? 14 of them. Okay, fun fact. All right, and then the last thing, probably can see it coming, but if you divide mixed numbers, same as with multiplying, you must change into improper fractions first. Improper fractions first. Okay, if you divide mixed numbers, you must change them into improper fractions first. Okay, and we'll do one of those. What am I up to? 3 on this one. So let's say you had 2 4/5 divided by 1 1/3. Okay, before you do anything, you must change those into improper fractions. So 2 times 5 is 10, plus 4 is 14. 1 times 3 is 3, plus 1 is 4. And notice I am not doing the keep, change, flip step at the same time that I'm changing these improper. That's too much to do at once. I will definitely make a mistake. So please make it 2 separate steps. So here's one step, showing me you know how to turn them improper. The next step is showing me that you remember that you are going to multiply by the reciprocal, keep, change, flip. All right. Look for any reducing. The 3 and the 5, no. The 4 and the 14, actually, yes. We can divide those both by 2. So that gets knocked down to a 2. That's a 7. 7 times 3 is 21. 5 times 2 is 10. How many times does 10 fit into 21? Twice, right? 10 times 2 is 20. 1 more to go. 2 1/10. And again, if one of those were negative, then your final answer would be negative. If both of these were negative, your final answer would be positive. So Lots to think about, but you guys can do it. Go slow, go step by step. All right? Good job.